So guys, you're exactly right when you talk about how do you describe the heights of people in here when you say, well, I would find the shortest person and then measure all the way up to the tallest person. We'll be describing heights from the shortest person to the tallest person. Maybe if I talk about age. What do you think? 14 right now? 13? 15? And 14's in here? Okay, so 14 all the way up to, you want to guess? 42, good guess. Okay, you remembered, right? Okay, 14 all the way to 42. I would say the ages in this room range from 14 up to 42. All right, so we're going to talk about intervals today and how we describe them being between numbers. But we're also going to talk about intervals where you might be less than one number going this way. You might be like less than 5 going this way, and you might be greater than 20 going this way. And in that case, we'll talk about what that looks like here in a little bit. But the whole idea today in section 2.5 is to look at solving compound inequalities, okay? I think the new term for you guys today is what is a compound inequality, all right? So this is the word that's going to be kind of new for us today. How about volunteer to read that essential question for me? Volunteer to read my essential question today. You got Dallas? You know always read for me.
How can you use inequalities to describe intervals on the real number line?
Okay, so inequalities to describe intervals on a real number line. All right. So in order to do that, we'd be able to write and graph compound inequalities. We're going to look at solving compound inequalities, and then we're going to use compound inequalities to solve real life problems. Okay. So the first thing we need to understand is what is a compound inequality. Okay. Compound inequality is going to first of all use the words and, or, they might use or. Okay? And a compound inequality is going to be something that shows certain kinds of intervals. And I think rather than giving you a verbal definition today, I'm going to give you a visual definition on what these really look like. Okay? Any compound inequality using the word and is going to look like the following. Okay? It's going to be some kind of interval. It's going to cover a certain interval of numbers. It's going to cover some numbers, but not all numbers. And it's not just going to be one inequality. It's going to be multiple inequalities that we're talking about. Okay? So the one that uses and is going to look like the following. Okay? You might have an inequality that looks like this. Okay? I don't care what the numbers are, but when you shade it, you might shade to the left of this, and you might shade to the right of this. My question is, where's the overlapping going to be between those two graphs? In between the dots or outside the dots? It's going to be in between where they overlap, right? So an interval is going to talk about something like this right here. What part's graphed in here? We're going to be looking at an interval of numbers on a number line from, like we talked about with our heights, maybe something that's the least up to the greatest, okay? Another compound inequality situation that you're going to run into is going to look like the following. Anytime you use a conjunction or to describe inequalities that we're going to look at today, and this will make better sense as we get into the examples, you might have something that looks like this graphically. You might have a number here, and you might have a number here. But instead of overlapping between the 2 points, you might have a graph that goes this direction and a graph that goes this direction. Okay? And that would be a compound inequality that doesn't have any overlap. We're saying we're going to include all numbers, but we're going to not include the values in this interval right here. Okay? I kind of talk about it as this. I always say, is this going to be an interval, or is it going to be, I always call this like whiskers. You guys okay with that? You see what I'm talking about when I say it, this one with the conjunction or looks like whiskers? Okay, so when I ask you today about the graph, I'm going to say, is it an interval or is it whiskers? You understand what I'm talking about there in terms of the visual? Give me some kind of head nod so I know it's you're alive this one. Okay, there we go. There we go. Okay. All right, let's rock and roll here today. First things first. this front-loaded question, I want you guys to take a minute, read through that, and then see what you come up with. I don't care if you're right or wrong right now to start, but we'll talk about what you're thinking here, and we'll see if we can't come up with a graph for this situation. So go ahead and read through that. When you get an answer or when you think you know what you should do, talk with someone at your table and see what you would do, or talk about what you might do in order to answer this, okay? So take a minute or so and go ahead and do that. I'll give you guys about 30 more seconds here. Okay, I'm going to go ahead and read this quickly, and I'll get your thoughts on this. But first of all, it says, every state has a law in the books that says something along the lines of, a person shall not drive a motor vehicle at such a slow speed so as to impede or block the normal and reasonable forward movement of traffic. Okay, what the heck does that mean? Well, right down here, some states specify what's called a minimum speed limit for highway driving. In Iowa, out on the interstates, what's the minimum speed? You've seen those signs before. What's the minimum speed that says that you can go? 40, but it says on 4 lanes that the maximum speed is supposed to be what? 70. By law, that's what we're supposed to do, okay? It says, what would the graph of the legal speeds look like in Iowa, and how is that represented, okay? Well, first of all, what values are we even referencing here in terms of the speed limit on a 4-lane highway in the state of Iowa? What speeds are we referencing? 40 and 70. So let's maybe put a graph together. Maybe you did that already. And I don't care if your graph matches mine perfectly, but I'm just going to do this right here. I'm going to say maybe 40's right here. Okay? We'll call this value 40. And I'm going to go by 5. So 45, 50, 55, 60, 65, 70. Maybe 70's right over here for me. Okay? So somewhere on your graph you need to reference 40 and 70. Okay. Now let's talk about what this looks like graphically, kids. If I had to ask you guys to graph the possible speeds, you're obviously going to tell me where to graph. Would I graph between the 40 and 70, or would I graph to the outsides of it? Am I supposed to drive less than 40, kids? No. I can't go less than 40. So can I graph anywhere left of 40? No. Can I go 40? Is 40 okay? So is that open dot or closed dot on 40 correct? So it should be closed, and that's what we have. Can I go above 40? I can go above 40 up to what? So the question becomes this: what's this going to look like graphically? Where would I shade that represents the possible speeds I could drive on a 4-lane highway? Where would you tell me? What should I graph? Where should I shade so that these are possible speeds that I could drive on the interstate? In between, okay? You're saying right here, you know what? We can drive any speed between 40 and 70. Okay? Now, here's the deal. When you do something like this, you're going to start asking yourselves, how do I write the inequality for this? Well, first of all, take a look at the visuals where we have multiple inequalities right here. Do I have an interval or do I have whiskers in the front-loaded question? An interval. And an interval is always going to relate to which word or which conjunction here? And. Okay, so here's what I'm going to do, kids. You are going to write the following. You're going to say that our speeds, is it okay if I use S as a variable? We're going to say S has to be greater than or equal to what speed, kids? 40. And what else? Less than or equal to, I'm sorry? 70. Thanks, Maddie. Okay. All right. The speeds that would work, you have to be greater than or equal to 40, and you have to be less than or equal to 70. This is implying some kind of what we call interval. Okay, an interval. An interval is going to have a low end and a high end, and you're going to shade in between those. Okay. So let's kind of move on here. Let's take a look at these here. Okay. Anybody need more time on that page? Anybody have any questions that page right there? You guys are good. All right, let's roll here. Okay, so examples of intervals. I need to check something here quickly. Give me 1 second, would you? Okay, very good. I like this. Examples of intervals. Okay, an interval is always going to use which word, kids? It's going to use and. It will always use and. Okay, now I'm going to give you some kind of a form for this. Okay, intervals are always written in the following form. Okay. Okay. A written form of any interval is always going to be written in the following. Okay. Over here, what do I put over here first, kids? What's it say in this form? I want to put the small number or minimum over here, less than whatever your variable is, less than the what? Big number. This is kind of like saying x is going to be bigger than the small value, but x is going to be smaller than the big value here, okay? Let me show you what this means. Let's just talk about that 40 and 70 thing. Just pick maybe 40 to be right here again. That was our minimum speed in that example, wasn't it? What was the maximum speed we could drive, kids? I might put 70 right here. Okay? And we were shading in between. Okay, our job right here is to write an inequality for that. Okay? The way you write an inequality for this right here for an interval is the following. Okay? We said our speeds had to be greater than or equal to what, kids? 40. And the way I wrote that in the other one, I put S out front, but in intervals right here, watch what I do. I'm going to say X. That's kind of like our speed. The way I've written this right here, we're saying X represents all shaded values right here. Everything in this shaded value are the X values that we're talking about. Okay? Is every value shaded in here the way I've written this? Is X bigger than 40 the way I've written that? But it's also less than what, kids? So I put X is also, and then read it this way, less than 70. Okay, so what this is saying, we're talking about all X values greater than or equal to what here? But all X values less than or equal to 70. When we write intervals, we write it in that form right there. You always put the small number on the left, big number on the right, put your variable in the middle. These signs will always be what kind of signs right here? For an interval, what kind of signs will these always be? Less than signs. They always have to be a less than sign. Okay. Now, you're going to get asked today, what type of interval is this? Okay, what type of interval is this? What do you notice about your dots here? Open or closed? Closed. You're going to say this is a closed interval. When I say the interval is closed, that means that the two values on the ends are included in the interval. Okay, this is closed because both dots are shaded. So, I'm going to throw some numbers up here, some graphs up here, and you're going to help me. Let's do this. I don't care where you put them. You don't have to be perfect on where you put the dots, but I'm going to do this. I'm going to put an open dot, say, right here, and maybe a closed dot right there. I'm going to put negative 16 over here. You guys give me another value. Bigger than negative 16. How much? 20 is what I heard first. Okay. I'm going to shade in between here. Here's this graph. Okay, how many of you, first of all, think you could write an interval for that given? I should say this. How many of you could write a compound inequality for that given interval? That's what I should say. Write a compound inequality like this right here for this interval using this format right here. Give me a show of hands. Bree, help me, kiddo. Negative 16? Less than x. How many agree with what Bree said there? Anybody have anything different? Bree, can I ask a question? Why less than right here? Why not less than or equal to? Not shaded in on negative 16. Why less than or equal to on 20? Do you guys agree that if we're talking about all x values that are in this shaded region right here, are all these x values in red bigger than negative 16? Are all these x values in red less than or equal to 20? They are, aren't they? Okay. Let's see. If the top one was called a closed interval, anybody have a question what this one, or guess what this one might be? One closed, one open? All right, I'll just tell you what it is. It's called half open. Okay, if one's open and one's closed, you call it a half open interval. Okay? Half open interval. All right, I'm going to have you guys try these two on your own, so I'm going to put some values up here. Oops, let's back up. No, shade that first dot in. All right, go ahead and write an interval for that one. And then write an interval for that one. All right, Walter, go write the first one for me. Walter, write the first one for me. Your penmanship's nicer than mine, I'm sure. I'll bet it is. We'll vote here. We'll have a vote.
It's highlighter.
Yeah, change it to the pen. Just change the color down there. Pick like black, red, or blue down there. There you go.
Yeah. Okay. This is hard to use.
No. Hit the arrow button back up there. See that curved arrow up there?
Oh.
Okay, there you go.
Okay. I'll try this again.
All right, so
30.
31. equal x. We're talking about all values bigger than or equal to 31, but at the same time less than 42. How many have that first?
That's so bad.
Okay. Hey, if the one prior to that was half open, what do you think this one is?
Did you write that too?
It's also what? Half open as well. Bree, what are you doing? Holy smokes.
Okay. Wait.
Yeah.
Wait.
It doesn't.
Now what?
Off the side, actually.
I'm
Does it
I'm
depend?
breaking it.
There you go.
Oh.
You okay?
It's like off. Okay, this is great. This is great handwriting, guys.
It says half
Why
open.
is it like that?
Boy, I might be wrong for the first time in my life. My penmanship
Why
might
is
be a
it
little
like
better.
that?
Okay, thank you. How many had that? 30. I'm concerned about writing the inequality. Okay, and this would be an interval. So this is saying x is greater or equal to 31 and x is less than 42. That's what that's really saying. My next one right here, kids. What did you have on the left? 16. Which sign? Less than x. Very good. Okay. If the very top one was a closed interval, what do you think this is? It's open on the ends, okay? It's open. Very good, guys. Very good. All right, I'm going to tell you this right now. This gets tricky for kids. Some of this stuff can get tricky for kids. Do you understand this format on the left over here for intervals right now? Okay? Anybody understand that for intervals? If you see values shaded between 2 points, always go back to this, okay? These are intervals. Okay, so let's talk about infinite intervals. Infinite intervals are like the following. They're going to first of all use the conjunction or, and they look like, what are we going to call this here, kids? They look like whiskers. Okay? And your whiskers are always going to take on the following form. Okay? Your written form will always be like this. It'll always be x greater than the big number or x less than some kind compared to the small number. Okay, this one here you have to write two separate inequalities and you have to use this conjunction or right there. Okay, so as an example, give me two values. I don't care what they are. How much?
7 and 10.
7 and 10. Here's 7, here's 10. Okay, I don't care where 7 and 10 go, just put them in relative spots so that they're at least ordered from least to greatest. I'm going to shade to the left, and I'm going to shade to the right. Okay, we call this infinite intervals because we have one interval that's going to take off and run to the right forever, and we call this one an infinite interval all the way to the left. Okay. Problem is, are we including all values or are we leaving some out? Well, we're leaving some of these out here, and here's how you would write this, okay? How would you write an inequality relative to 7 right here, kids? All these x values that are shaded right here, how would you write an inequality for x compared to 7 right there? So we're going to say, we're talking about the graph of all x values less than or equal to what, kids? 7. We can be in here, or we could be over here in this shaded region. So what will we say here? Relative to 10. Very good. Okay. Very good. X is less than or equal to 7, or x is greater or equal to 10. We use the conjunction or when we have what type of a graph, kids? Very good. Very good. Let's try a few more here. Ready, kiddos? I see people writing. Let me know. Give me a show of hands. Everybody ready? All good? Thumbs up? All good? That side good over there? Okay. Next page. So example 1, writing and graphing compound inequalities. Okay, first of all, we have to write these. It says a number C is less than 5. Notice what I underlined right here, kids. What word did I underline here in example 1? And. Okay? And greater than or equal to -2. First of all, it uses the conjunction and when it compares two inequalities. Okay? So is that going to be an interval or is that going to be whiskers? It's going to be an interval. Okay? Put your two reference values down here, kids. What's your reference value first? 5. Pick 5 to be somewhere. I don't care. I'm going to put it right here. What's my other reference value? Find -2. And when you get the assignment today, you'll have those values labeled. Okay. It says C is less than what, kids? 5. Open or closed on 5 then, if it says C is less than 5. Open on 5. It says greater than or equal to -2. Okay? It uses the conjunction and, so where is the shading going again, kids? Interval, inside. Interval inside the points, okay? I think graphing them is the right thing to do first. Okay, because once you have them graphed, you have the form for being able to write the compound inequality for that. Okay? Anybody want to take a shot at the compound inequality for this example? Going, Bree? All right. -2. Okay, and just be careful. I agree X would work, but in this example, they're actually using excellent. Less than 5. Okay, that's what would be the written part there. Okay. So the first thing I did here was I said, am I using and or here? Using and. I labeled my reference values, I shaded in between, and I used the proper form to write the compound inequality. Okay? So I'm going to ask the same set of questions in the next one. It says number t is less than -1 or greater than or equal to 4. Okay? Which conjunction am I using? Am I using and or? Or. Okay? All right, let's get our reference values down there. What values should I reference first, kids? -1 somewhere. I'll put it right here. And what else? Okay. All right, so it says a number t is less than -1. So open or closed on -1? Or greater than or equal to what? So open or closed on 4, kids? Closed. Okay. So since we use that conjunction or to describe two inequalities right here, am I going to have an interval shaded or am I going to have whiskers shaded? Yep. Boom and bloom. So you're going to look at your form for writing compound inequalities. In this case, this is 2 infinite intervals. We're going to say, how does x compare to -1, kids? Oh, I'm sorry, not x. Which variable are we using here? T. How is t comparing to -1? How are all these t values that are shaded compared to -1? Less than -1. Or, what's my other one? T would be greater than or equal to 4. There it is. There it is. Okay, I don't want you to freak out too much about these next 2 examples. Okay? It's really pretty simple to do. They're trying to throw you a curveball. Don't let them. Okay? If they throw you a hanging curveball, what are you going to do? You're going to hit it where? Out of the park. Okay? That's your job. Anytime they hang a breaking ball to you, anytime they hang a curveball to you trying to do this stuff, you do what? Hit it out of the park. Solving and graphing inequalities, and in this case, compound inequalities. Okay? Anytime we've solved anything in here, our job is always to get a variable alone, isn't it? Same game here. You just basically, instead of having 2 parts to work with, how many parts do you really have to work with here now? 3 of them. Okay, listen. You guys all agree x is right here, right? And in that interval, you have x plus 1, don't you? How are you going to get x alone? What would you have to do within that middle part to get x alone? Subtract the 1. But how many parts now do I have to subtract 1 at?
3.
There's 3 parts. Okay, so how do you solve compound inequalities? Same thing. Instead of doing one thing to one side and one thing to an opposite side, or one thing to 2 different sides, you now have to do it to 3 parts. We're going to subtract 1 everywhere. This is what we get when we solve this. What is -3 minus 1? Clear over here. -4. Kids, does subtraction have any? Well, Does subtraction change the direction of a sign at all? No. So this less than is going to stay a what? Less than. What are you going to have in the middle, kids? And less than what? Okay, my question is this. That form, the way it's written, is that going to be an interval graph or is that going to be a whisker graph? It's going to be an interval. We're saying we're graphing all numbers between -4 and +4. Open or closed on my ends? Open. Here's your graph. Okay, now that one was pretty easy. Subtract 1 from everything, and then you're on your way. Okay, this next one, you may want to put a star by. Again, what are we trying to get alone when we solve inequalities? Trying to get x alone, right? Okay, watch what happens here. First of all, in here, x is in the middle again. Quick question, kids. What do you think you're going to do to all three parts first? Not -4, but add 4 first. All agree? Okay. So you were saying get rid of the -4. Is that what you were saying, Matt? Okay, I agree now. Okay, I'm going to skip down a little bit. What's -7 plus 4, kids? -3. Is addition going to have any effect on the direction of your inequalities? Nope. All right. What's going to be in the middle right now after I added 4? -3x, and then less than or equal to, what are you going to have on the right side, kids? 6. Now I'm going to change the pen to red right now because what's your next step in getting x alone? Divide by -3. And in this case right here, when I divide by -3, what is going to happen? Going to change all my signs, right? Okay, I want to make sure you understand what I'm about to do. The way I would do this here first is this. The -3 divided by -3 really turns into what value? 1. Okay? The less than sign, since I divided by a negative, is going to turn into a what? Greater than. This is just going to be x in the middle. How about the 6 divided by -3? -2. So less than or equal to is going to turn to what? Greater than or equal to -2. Now this form looks like what we've talked about, but the problem is I don't have less than signs. We now have what? Okay, take a look at these two values, 1 and -2. Which value is the smallest one? Okay, so when you get something that flips a sign with an interval, go through and do this. Put your smallest value back on the left. When I flip everything around, take your sign with you, but also do what with that sign? Flip it around. Less than or equal to your x, less than what value over here? 1. Okay, check it right now, guys. Just look at the x and the -2 right here and what we got for a solution. This is saying x is greater than what, kids? X is bigger than -2. Doesn't this say x is bigger than -2 the same way? Okay, this here said x is smaller than 1. Doesn't this say x is smaller than 1? So within your process, if you ever divide by a negative and stuff changes right here, make sure you put it back in that form that puts the smallest number on the left, variable in the middle, biggest number on the right. Okay, open or closed on -2, kids? -2 shall lie here. Open or closed on 1? And where are you shading, kids? That's interval form, so in between. Perfect. Give me a show of hands. How many are kind of on with me right now? How many know where we're at? Know what we're doing? Awesome. Okay. All right, let's check the next page here. Anybody need more time getting that stuff down? Page 3? Okay, we're almost done here. Almost done. Page 4. Solving infinite inequalities is very simple. You just solve them. And then, you know what? If an inequality starts out with or, is this going to be an interval or a whisker graph, first of all, kids? It's going to be a whisker. So help me solve the one on the left. What would you do to this on the left first to solve, kids? This inequality on the left, what would you do to get x alone apart on the left here before or? So subtract 6. So you're going to have 2x less than -8 when you do that. And then you're going to divide by 2. And x is going to be less than what, kids? Negative 4. Okay, there's one part of it. Bring your conjunction or down, and then solve the other one. What are you going to add to both sides there, kids? Add the 5. So 4x will be greater than 8. And when you divide by 4, x is going to be greater than what? So which values am I referencing on a number line? Negative 4. Positive 2. Whisker or interval, kids? Meow. Okay, that was bad, I guess. Nobody laughed. Excellent, kids. One more example to go. We'll apply this to some real life stuff, okay? I've always said that if you tell your family you love them, you'll laugh and you have what? Candy. Those 3 things happen a day, no matter what else happens. It's what kind of day. It's a good day, right? Okay. So, right here, solving a real life problem. Let's talk about some of my favorite stuff right here in the world. A recommended storage temperature for, everybody say it? Chocolate is 15 degrees Celsius to what? Okay, they're saying keep it between what values? 15 and 20. Is this an interval or is this a two infinite inequality? It's an interval. We have to be between 15 and 20. Okay? They're asking you guys, since we're American right here, we want to go ahead and change this into what? Fahrenheit. Okay, it says write and solve a compound inequality that represents the possible storage temperatures in Fahrenheit using the formula that Celsius is equal to 5/9 times your Fahrenheit minus 32. We need to figure out what 15 and 20 are in terms of what? Fahrenheit. Okay, so let's do that for the 15 Celsius right here. Whoops. Okay, in this formula that we're about to use right here, C equals 5/9 times your Fahrenheit temperature minus 32. Is this 15 a Celsius temperature or is this 15 a Fahrenheit? It is a Celsius. So in this formula right here, would I be plugging 15 in for C or F? Let's do that. We're going to plug 15 in equals 5/9 times F minus what, kids? Okay, how do I get rid of this fractional coefficient out front? How do you get rid of the 5/9? Multiply by the, which is 9 divided by what? Well, 9/5, right? Okay, help me, kids. Let's do the part on the left. What's the 15 divided by 5 get you? 3 times 9 is? So the value on the left is 27. What do the reciprocals of each other do on the right? And what are you left with over here? F minus 32. So we plugged in 15 degrees Celsius. How am I going to figure out what that is in Fahrenheit now based on where we're at in the formula? Add how much? Add 32. Add 32. Help me if my math is correct. I get 59 is the same as 15 degrees Celsius. 59 Fahrenheit is 15 Celsius, okay? Now we need to do the same exact thing for the high end in Celsius. We need to do the same exact thing for what? 20 degrees, so let's do that. Okay, so in this formula right here, what am I plugging in for C? So 20 degrees Celsius is equal to 5/9 times F minus 32. How am I going to get rid of that fractional coefficient again, kids? Times the reciprocal. I like how you said that. Say that again. Times by the reciprocal. That's awesome. I like that. I'm going to say that all day now. What's 20 divided by 5?
4.
4 times 9. So the left value is 36. What are my reciprocals of each other going to do? Cancel. And what are you left with on the right side, kiddos? Okay. What do you have to do to both sides? Add 32. And I think I get 68 for that. So a 15 to 20 degrees Celsius is what I had to keep the temperatures between, to keep that chocolate good. What Fahrenheit temperatures are we really talking about? 58 to what? So they want us to write an acceptable inequality that would get us any temperature value. So we want temperature values between what and what, kids?
59 and 60.
So this is going to be an interval. So I'm going to put my small value on the left, 59 degrees. Would be less than or equal to our temperature, and let's use what variable here, kids? F, right? And that would have to be less than or equal to what, kids? Okay, they're saying these Fahrenheit temperatures need to range from 59 to 68. And that would be the compound inequality for them. Okay? All right, any questions about anything there? Your compound inequalities, again, if you look at the forms, what's an interval? What do two infinite intervals look like? We call it two infinite intervals. What's the word we're going to use to kind of keep it up here? Okay, the whiskers would be the graph. We'd talk about and or. I would say refer to your notes to see the forms on this, okay? So, again, this will be something we spend some time working on tomorrow as well in class a little bit. You'll kind of have a work day on things, but anybody have any questions before I tell you to get going on the online page, though? Okay.